Okay, we now have one composite argument property. Cosine of A minus B is cosine A cosine B plus sine A sine B. Now we're going to derive three others. The first one is cosine of A plus B. Well, we need to use something we already know, and we already know cosine of two angles subtracted. So we're going to rewrite A plus B as a subtraction, as A minus a negative B. Then we are going to apply the property above, substituting negative b for b. So it's going to look like this. Cosine A cosine negative b is plus sine A sine negative b. We want to rewrite that so it doesn't have any negative signs, and recall the odd-even property, which tells us that I can replace cosine negative b with cosine b because they are equal to each other. But sine of negative b becomes negative sine of b because they are equal to each other, and that is supposed to be a b there. Multiplying sine of a times negative sine of b gives us a negative sine A sine b, so the property ends up looking like this. Cosine of a plus b is cosine A cosine b minus sine A sine b, which maybe you could have guessed from the original property. The only thing that changes is the sign. Notice on the cosine A and cosine B that the sign is opposite in the property of what it is in the argument. Now the next one we're going to do is sine of A minus B. And sine of A minus B has to be written as a cosine problem because the only other properties we know are cosine properties. So recalling the cofunction property, I can write that sine of the angle A minus B is the same as cosine of 90 minus that same angle, A minus B. Then I am going to do a little clever transformation here, and I'm going to distribute the negative sign, which gives me 90 minus A plus B, and then I'm going to regroup. So I'm going to say that 90 minus A is my first angle, and B is my second angle. So now I've rewritten this as an addition of two angles. So I'm going to go back and apply the property cosine A plus B with 90 minus A as angle A as the first angle and B as the second angle. So notice I'm going to use this framework here, and I'm going to say cosine 90 minus A cosine B minus sine of 90 minus A sine of B. Then I can apply the cofunction property again and change 90 minus A, cosine of 90 minus A to sine of A, and sine of 90 minus A to cosine of A. So I have sine of A minus B is sine A cosine B minus cosine A sine B. So notice the signs are the same here, the sine A minus B here and a minus over here, but now I have sine cosine cosine sine. I start out with sine A and cosine B, then I go to cosine A sine B. The last property I want to look at, oops, I switched where I didn't want to switch. The last property is sine of A plus B, and we're going to handle that just how we did cosine of A plus B. I'm going to rewrite sine of A minus B as, or sine of A plus B as a subtraction. So I have sine of A minus a negative B. Then I'm going to apply the previous property, which uses sine of A minus B, only every place there's a B, I'm going to substitute a negative B. So I have sine A cosine negative B minus cosine A sine of negative B. Applying the odd-even property, cosine of negative B becomes cosine of B. Sine of negative B becomes negative sine of B. A negative times a negative is a positive, so this just becomes positive here. Sine of A plus B equals sine A cosine B plus cosine A sine B. Now, what's a good way to remember these four properties? Because I will want you to memorize them. So I'm going to write, here they all are written together, and you might want to write them down on your trig property list. So how can we tell the difference? I'm going to tell you a little story to help you remember them. Once upon a time is probably not a good, but the cosine functions decided to have a social get-together. And the sines arrived first, and they were very excited because they really liked to meet new people, and they couldn't wait for the cosines to get there. But when the cosines got to the party, they all went and sat at a table all by themselves and really just didn't want to have anything to do with the sines. Notice that when the cosines are together, when we have cosines, the cosines sit together and the sines sit together. They are very cliquish that way. Also, notice that the cosines, if you say minus, they say plus. And if you say plus, they say minus. They're very contrary. They're just not good to be around. They're cliquish, they're contrary. They don't want to have anything to do with the sine. So I'm not sure even why they came to the party in the first place. The sines, on the other hand, love to mingle. They're very friendly. They're very agreeable. If you say minus, they say minus. If you say plus, they say plus. They like to mingle. Sine, cosine, cosine, sine. Sine, cosine, cosine, sine. So if you will remember that cosines are cliquish and contrary, whereas sines are social and agreeable, then hopefully you will remember your trig function properties. One other thing to point out is that we always start out with A first. With the cosines, we start out with cosine A. With the sines, we start out with sine A. So don't get mixed up with that. Now, last thing to do is to apply our new property to a problem. So once again, I have my special triangles written down. I've found the sine, cosine of 30, the sine and cosine of 60, and the sine and cosine of 45 using my special triangles. So I'm already with those trig values ready to go. And we're going to look at an example here. We want to find sine of 30 plus 60 by letting 30 be A and 60 be B in our property sine of A plus B. Now hopefully you recognize that sine of 90 is 1. This is sine of 90 and sine of 90 is 1, so we should get 1 at the end. Sine of 30, based up here, is 1/2. Cosine of 60 is 1/2. This actually illustrates the cofunction property. Sine of 30 is the same as cosine of 90 minus 30, which is 60. So these two should be the same. Cosine 30 and sine 60 are both square root of 3 over 2. So when we multiply together these two, we get 1/4. We multiply together these two, we get 3 over 4. Add them together, we get 1, and 1 is sine of 90. So that verifies the property. So try doing number 2 yourself, finding cosine of 75 by calculating cosine of 45 plus 30 degrees using cosine of A plus B. Leave your answer in radicals and then check your answer on the calculator just like we did with cosine of 15, and you should see that you get the same number. Try to work the problem yourself and then pause the video for a second, or maybe pause the video, try to work the problem yourself, and then turn it back on and I'll show you the answer. Okay, here is the answer. Cosine 45 minus cosine 30 minus sine 45 sine of 30. You fill in these values for sine of 45 for the various trig functions, and you end up with square root of 6 minus square root of 2 all over 4. And if you check on the calculator, then you can see that cosine of 75 degrees is equal to square root of 6 minus square root of 2 all over 4. So this is just an example. Now, would you work a problem like this realistically? No. This is just a numerical example to show that the property works. These properties in and of themselves aren't used as much as they are used to prove other properties that get used more often, say in calculus. So the next video will show how we use then the composite arguments and some other properties that we already know to prove double argument properties.